Sorry, I had something in my throat. Anyway, hi friends. Welcome to our 6th class of Unit 5, where today we want to continue and deepen our exploration of solving systems using this method that we call interchangeably combination or elimination. And if we're going to do that, it might behoove us to remember, well, what is it exactly that we're trying to accomplish? What's the idea behind how this method works? Take 10 seconds, pause the video, look back at your notes. What do you think? Go! Okay, well, in order to solve something by combination or elimination, it's in the name. What I'm trying to do, big picture, I want to find a way to combine two of the equations in my system in order to eliminate, hence elimination, one of the variables in those equations. Again, mathematically, what does it mean to combine two things? If I'm combining these equations, what am I doing to them? 5, 4, 3, 2, 1. Very good. If I'm combining two things, that means either I'm adding them or subtracting them. So I want to find a way to either add or subtract my equations together so that a variable cancels out. However, what if I'm in a position like this? A plus b equals 7, 2a minus 3b equals negative 11. Notice, if I add the two equations together, a and 2a, b and negative 3b, neither of those are going to undo each other. If I subtract a and 2a, b and negative 3b, neither of those will undo each other either. So, if I want to use my strategy of elimination, I might need to change my approach a little bit. What do you think I might need to do if there are no common coefficients, if I'm not in a place where I've already got two things that will nicely undo each other using addition or subtraction? Take 30 seconds, pause the video, take a risk, take a chance. What do you think I might be able to do? And the hint that I'll give you, your superpower as a mathematician, is to make things look the way you want it to look. What choice could I make to one of my equations to make this look the way I want it to look? Go. All right. The problem is that we do not have any coefficients in common. So what that tells me is if I don't already have one, I probably want one. And in order to do that, what I need to do is find some common multiple that I can use to my advantage so that when I do addition or subtraction, they will be able to undo each other. You could do this with either A or B. For the sake of time, I'll show you how to do it with A. But again, you could make either choice. Mathematics is all about freedom of choice. So say here that I want to get rid of the A's. I want to eliminate the A's. What that means is I need to find a way to turn the A in the top equation into a 2A. Well, if I want to turn the A in the top equation into 2A, I should probably multiply it by 2. But remember, it's an equation. So if I do something to one part of an equation, I need to do something to every part of the equation. So I can't just multiply A by 2. What I'm actually going to do is multiply the entire equation by 2. When I do that, right, rewriting the equation on top here, after I multiply by 2, well, 2 times A is 2A, 2 times B is 2B, and 2 times 7 is 14. Carrying down the rest of my system, 2A minus 3B equals negative 11, notice I'm now in a position where I can undo my 2 A's. What operation would I want to use here to get rid of my A's? Go! All right, hopefully you've got it. Let's do some subtraction. So doing some subtraction here, I'm in familiar territory. 2A minus 2A is 0, those go away. 2B, or not to be, minus negative 3B. Well, that's 2B, or not to be, minus negative 3B is plus 3B. So 2B, or not to be, plus 3B is 5B. And then finally, 14 minus negative 11, that's 14 plus 11, which is 25. 5. Dividing both sides by 5 to get b by itself, b is equal to 5. And now that I know b is equal to 5, I'm home free. I've just got to substitute into one of my equations to get the value of a. Thinking caps, where's the wisest place to plug back in here? 5, 4, 3, 2, 1. Well, I would say this equation right here, before I multiplied by 2, is going to give me the nicest, friendliest numbers to work with. So I know a plus b is equal to 7, but b, we've said, is equal to 5. So that means a plus 5 is equal to 7, doing our substitution. Subtracting 5 from both sides to get a by itself. That tells me a equals 2. Fantastic. If I wanted to, how would I write this as an ordered pair? 5, 4, 3, 2, 1. Well, a comes before b in the alphabet, therefore 2 is coming before 5 in the ordered pair. Lovely. If you wanted to, you could also have multiplied the top equation by 3. Then notice you'd have a 3b and a negative 3b. Those you could absolutely undo using addition. So you can do this with either variable you prefer. I've showed it to you one way. If you're interested, feel free to check on your own by multiplying the top equation by 3. You should still get 2, 5 as your solution. Great. Let's do another one to really make sure that this idea sinks in. 5f plus g equals 1. 10f minus 4g equals 26. Which equation here could I multiply by some number to get myself to a position where I can undo either the f's or the g's using elimination? Take 2 minutes, pause the video, see how far you get. Can you find the values of f and g? Go, go, go. And stop. I was really tempted to scream at you again, but I don't want to start hacking up a lung. So 5f plus g equals 1. Let's say that I want to turn 5f into something that is cancel-outable, not a rigorous term, but hey, with 10f. If I want to turn a 5 into a 10, let's multiply this entire top equation by 2. So I'm going to multiply the entire top equation by 2. 2 times 5f is the 10f that I want. 2 times g is 2g. And 2 times 1 is 2. Bringing over the rest of my system here, 10f minus 4g equals 26. I am now in a position where I can do some elimination. From here, if I have 10f and I want to undo them, let's subtract. So I'm going to subtract 10f from 10f. That's going to leave me with 0. 2g minus negative 4g is 2g plus 4g. That gives me 6g's in total. Then I've got 2 minus 26, which is negative 24. To get g by itself, all I've got to do is divide both sides by 6. That tells me g equals negative 4. Knowing that g equals negative 4, again, thinking cap, where's the wisest place to substitute back in? 5, 4, 3, 2, 1. I would say that this equation, before I did my multiplication by 2, is going to give me the nicest, friendliest numbers to work with. Let's use that guy. So I know 5f plus g equals 1, but I've just said that g is equal to negative 4. Therefore, by substitution, 5f plus negative 4 is equal to 1. If I want to get rid of negative 4, let's add 4 to both sides to get f by itself. 5f is equal to 1 plus 4, which is 5. Dividing both sides by 5 tells me that f is equal to 1. F is 1, g is negative 4. How would I write this as an ordered pair? 5, 4, 3, 2, 1. Very good. Well, f comes before g in the alphabet. Therefore, as an ordered pair, 1 would come before negative 4. Beautiful. So sometimes we can get away with multiplying just one of our equations by some number to get to a place where we can use elimination. Sometimes, though, if you're thinking about where we're likely to go next, what if I'm in a position where multiplying just one equation isn't enough to get me to elimination territory? 2x plus 3y equals 3. 5x minus 4y equals negative 4. Notice there's no nice number. There is a number I could use. It would be a fraction, though. No nice number can turn a 2x into a 5x or a 5x into a 2x. No nice number can turn a 3y into a 4y or a 4y into a 3y, which tells us maybe I need to change both equations to get this to a place where elimination is possible. How do you think I might do that here? Take a risk, take a chance, take 30 seconds, pause the video. If you're thinking strategically, what choice could you make? Change both of your equations here to get this to a place where we can use elimination. Go. All right, let's do it. Well, the hint that I've given you, that's not really a hint because it's written in black right above. I might need to multiply both equations. Let's say, for example, that I want to get rid of the x's. I have a 2x and a 5x. Again, if I think back up to what we wrote before, in order to use elimination, I need a common multiple. So with this idea in mind, scrolling back down, I need a common multiple between 2x and 5x. That means that I want probably something like 10x, which is both a multiple of 2 and 5. So I want to turn 2x into 10x. In order to do that, I would multiply the top equation by 5. For the bottom equation, I want to turn 5x into 10x. That probably means I want to multiply 5 by 2. So I'm going to distribute my 2 here in the bottom equation, my 5 here in the top equation. Notice on top, 5 times 2x is 10x. 5 times 3y is 15y. And 5 times 3 is 15. On the bottom, 2 times 5x, there we go. There's that 10x that we want. 2 times negative 4y is negative 8y. And 2 times negative 4 is negative 8. I've got a system that is now eliminationable. Take 2 minutes if you have not already. Pause the video. Let's find x and y. Go. And come back. I'm lonely. So 10x and 10x, let's undo it using subtraction. 10x minus 10x is 0. 15y minus negative 8y would be 15 plus 8y. 15 plus 8 is 23y. 15 minus negative 8, again, that's 15 plus 8, which is 23. Dividing both sides by 23, that tells me y is equal to 1. Now that I know y is equal to 1, let's pick an equation to substitute back into. I'm going to choose the one on top because it has smaller numbers. 2x plus 3y is equal to 3, but we just said that y is equal to 1. Therefore, 2x plus 3 times 1 is equal to 3 by substitution. That tells me that 2x plus 3 is equal to 3 if I simplify. Minus 3 from both sides. 2x is equal to 0. Divide both sides by 2. That tells me x is equal to 0. And as an ordered pair, how would I write this? 5, 4, 3, 2, 1. X comes before y in the alphabet. Therefore, 0 is coming before 1 in the ordered pair notation. Fantastic. So as long as I can create a common multiple, I can use my strategy of elimination. Let's try it with one more, and then we'll hit the road. 3a minus 2b equals 11. 4a plus 3b equals 9. I want to use my strategy of elimination. In this case, notice I'll probably have to multiply both of these equations by some number. Take 2 minutes, pause the video, see how far you get. Let's find a and b. Go. And stop. So let's say, again, you could do the a's if you wanted to. Let's say that I want to get rid of the b's. In order to get b to have the same coefficient, I need some number that both 2 and 3 multiply to. The best number for that is probably 6. So I'm going to take the top equation. In order to turn 2b into 6b, I need to multiply by 3. In order to turn 3b into 6b, I'm going to multiply by 2. So from here, let's do some multiplication. Distributive property. 3 times 3a is going to give me 9a on top minus 6b is equal to 11 times 3, which is 33. On the bottom, 2 times 4a is 8a. 2 times 3b, there's our plus 6b that we wanted. And 2 times 9 is 18. Here's my new system. And would you look at that? I can now use addition to eliminate my b's. 9a plus 8a is 17a. Negative 6b plus 6b. These are going to undo each other. That's 0. And then I have 33 plus 18. That's equal to 51. Dividing both sides by 17 to get a by itself, that tells me that a is equal to 3. Knowing that a is equal to 3, I want to substitute my value of a back in to find the value of b. I'm going to pick the equation on top. I could use either one, but the equation on top has smaller numbers, so I want to use that one. It doesn't really matter, though. So I know 3 times a, which we've just established is 3, minus 2b equals 11. 3 times 3 is equal to 9, minus 2b, or not to be, equals 11. I want to get 2b, or not to be by itself, so I'm going to subtract 9 from both sides. Negative 2b is equal to 11 minus 9, which is 2. And finally, negative 2b, or not to be, I want to get b by itself, so I'm going to divide by negative 2. 2 divided by negative 2 is negative 1. As an ordered pair, how would I write this? 5, 4, 3, 2, 1, and stop. So I know that a comes before b in the alphabet. Therefore, 3 would come before negative 1 in our ordered pair. Fantastic. You now know how to solve any system of equations using combination or elimination. Congratulations, you done it. I will see you next time where we will talk about some funky systems of equations. But until then, take care, be good, drink some water, take a shower, and I'll see you when I see you. Goodbye.